Section 5.3 is about special factoring. There's really only one type of factoring from this section you're going to have to memorize. The rest are kind of shortcuts, but again, I won't recommend taking shortcuts in math. We can always use our same method of finding the factors of AC that add up to B, but I'd love to show them to you anyways. So if A and B are real numbers or an algebraic expression, then if I take if I have A squared minus B squared, that would factor into the sum and difference of two perfect squares. So the difference of two squares is going to factor into a sum and a difference of those terms. So for example, let's take x squared minus 36. Well, let's identify our capital A. A is going to be x. Let's identify our capital B. Well, I've got 36, which is 6 squared, so B is 6. So by this rule, this is going to factor to x plus 6, x minus 6. But what if I'd forgotten that rule? We can still use the factors of AB that add up to C, factors of AC that add up to B. And let me show you how. So if I have x squared minus, how many x's do I have? Well, I have 0x minus 36. I got to use a placeholder, just like when we're dividing polynomials. I need to now find the factors of AC that add up to B. Well, what are some factors of negative 36 that add up to 0? Well, that's 6 and negative 6. So I have x squared minus 6x plus 6x minus 36. We factor by grouping. I get x plus 6 times x minus 6. See, I would have gotten the exact same answer, but this is a little bit of a shortcut. Next, I have 4a squared minus 664. I need to go ahead and pull out that factor of 4, right? We always want to pull out the greatest common factor. So I left with a squared minus 16. That's going to give me x minus 4, because, a minus 4, because my big A is A. And 16, that's my B, which would give me 4. So that's going to factor to 4 times a minus 4, a plus 4. Now I have 16x squared minus 49y squared. So my a in this case, right, a squared is this term, b squared is this term. The square root of 16 is 4, so my a is 4. The square root of x squared is x. The square root of 49 is 7. The square root of y is y. So I have 4x plus 7y times 4x minus 7y. And again, you could solve this the old way if you wanted. All right, now I have x to the fourth minus 81. That's going to give me my a is x squared and my b is 9. So I get x squared minus 9 times x squared plus 9. The thing is, we can keep factoring this, right? If I have x squared minus 9, that's the sum and difference that's the difference of two squares. But now my a is x and my b is 3. So this fully factor would be x plus 3, x minus 3 times x squared plus 9. So we got to use our special rule twice. Now, this rule, I think, is the most unnecessary rule, but it's how to factor perfect square trinomials, right? So if I have a plus b squared, then I'm always going to have my leading term squared plus 2 times ab plus b squared. So here, if I have a is x and b is 3, my middle term is 2 times 3 times x, which is 60x, right? I would just go ahead and factor this by finding the factors of AC that add up to B. It's going to make your life simple. What if you accidentally do a miscalculation? So for these, I would always recommend to do it the old way. It's not any faster. So I find the factors of AC that add up to B. AC that add up to B, that's going to be 3 and 3. So I have x squared. Remember, we've got our little shortcut, so this would be x plus 3 times x plus 3, because a equals 1, or I could have done this a long way. and I would get x plus 3 squared. So I don't like this one. It's kind of a waste of time. Here are some more examples though, so I guess we should go ahead and do them, right? So I have, in this case, why don't we go ahead and identify for the next two our a and b. So here my a is 12x. Here my b is 5. So that's going to be 12x minus, because it's a minus there, minus 5 squared. Here I've got my a is 2x, my b is 7y. Right? But my middle term, which is supposed to be 2 times a times b, that's 2 times 2x times 7y, that's supposed to be 21xy, so you can't factor it using this method. I would have to find the factors of 4 times 49 that add up to 20, which I don't think there are any, so this is going to be prime. This is the only special factoring rule that you have to memorize. You must memorize this. And what this is, this factoring the sum and difference of two cubes. Remember, cubic equations are degree 3. So if I have the sum of two cubes or the difference of two cubes, the sum of two cubes factors into a plus b times a squared minus ab plus b squared. And the difference of cubes factors into a minus b times a squared plus ab plus b squared. You must memorize these. There's no easy way to derive these. So we want to start by identifying our a's and b's. Here I've got x cubed, so our a is going to be x. Here I've got b cubed, which is 27, so that's 3 cubed, so our b is going to be 3. Since we're finding the sum, this is going to factor into x plus 3 times x squared minus ab plus b squared. Let's try this again. Here I have 27 x cubed, so my a is going to be 3x. Here I have 125. You take the cube root of 125, you get 5. So I'm going to have 3x plus 5 times a squared, this one up here, a squared, which would be 9x squared, times, subtract ab, so minus 15x, plus b squared, so plus 25. For number 3, we need to pull out the greatest common factor, which is a 3, so I've got x cubed minus 8. This means my a is x and my b is 2. So this is going to factor into 3, because we can't forget our greatest common factor that we pulled out, times x minus 2, x squared, plus ab, plus b squared. And it's just going to be using this rule a bunch of times in order to get it memorized.